Hello everyone, this is Miss Berdine, and on this lecture video, we will be discussing calculations involving Gauss law. So we are more be focusing on the computations here. Now, for the first problem, we have here problem 1 related to electric field outside a spherical shell. So, a conducting spherical shell carries a total charge of 5.0 times 10 raised to negative 6 coulomb, and we have to find the electric field at a distance of 0.20 meters from the center of the sphere. So, the given values, we have the total charge of 5.0 times 10 raised to negative 6 coulomb. The distance from the center is 0.20 meters, and the permittivity of free space, this is constant, as I have discussed before, is 8.854 times 10 raised to negative 12 farad per meter. So we will be having the permittivity of free space since we're dealing with electric field outside a spherical shell. Now, to solve this problem, we will be having the following solution. So, from the Gauss law, the electric field outside a sphere behaves like a point charge. So, in that sense, we will be using this formula, and we all need to do is, let me clear the board. We all need to do is just substitute the values from the previous. So, for the total charge, we have 5.0 here. And then for the given 4 pi, take note of the units. We have 8. Then we have the permittivity of free space of 8.854. And then we have the area, which is 0.20 meter, and that is raised to 2 as given in our equation. Then the next that you need to do is, of course, you have to cancel some units. You have meter squared, and then you have m, and then later on, performing those operations, you will have Newton per coulomb. And your answer should be 1.12 times 10 raised to 6 Newton per coulomb after you input those values in calculator. Alright? So we should have the same answer. Now moving forward for problem number 2 on flux through a cube enclosing a charge. So the problem is read as a charge of 3.0 times 10 raised to negative 6 is placed at the center of the cube. So we have to find the total electric flux through the cube with the given values of charge that is enclosed, 3.0 times 10 raised to negative 6, then the permittivity of free space, 8.854 times 10 raised to negative 12 farad per meter. So on this problem, we will be using the total flux, the formula for that, which is total flux is equals to the total charge over the permittivity of free space. So you just need to substitute the values and then you will have the answer. So on your end, before I proceed to the key answer and solution, try answering this by substituting the given values to our formula. So what is your answer? Are you done? So moving forward, we have here the given values and the solution. So our solution, the total flux, this is the formula. And you just have to substitute the values. Given is the charge, total charge. Then the permittivity of free space. And then you will have the following computations. So the next thing that you need to do is what? What is the next thing that you need to do? So you will have to have the final answer of 3.39 times 10 raised to 5 Vm. Okay? Now, moving forward, try to input that in your calculator, no? We have here the following. Problem 3. The field inside a uniformly charged sphere. A sphere of radius r of 0.30 meter has a uniform charge density of 5.0 times 10 raised to negative 6 coulomb per cubic meter. Find the electric field at 0.10 meters inside the sphere. So our charge density at P is 5.0 times 10 raised to negative 6 coulomb per cubic meter. Our radius of sphere is 0.30 meters. 0.30 meters here it is given. Then the distance inside the sphere is 0.10 meters. Then the permittivity of free space is constant as always, and we have to use the following equation or the solution. Now, try solving those problems before I click the next slide. You just have to substitute the values in the solution. So for the uniformly charged sphere, the electric field is being read as this one here. The electric field equals the density of the charge uh, from the radius of the center over 3 and then the permittivity of free space. So we have the charge of the density that is given in the problem, the radius or the distance from the center of 0.10 meters, then 3, then the permittivity of free space that is constant. Now, performing the operation, the cancellation of methods, you should have the final answer of 1.88 times 10 raised to 4 Newton per coulomb. So you may use your calculator directly in solving this. Now, next one is we have electric field near a long charge wire. So we have a long cylindrical conductor that carries a charge per unit length, which is represented as lambda, of 2.0 times 10 raised to negative 6 coulomb per meter. You have to find the electric field at a radial distance of 0.05 from the axis. So on this point, the given values is the charge per unit of length of 2.0 times 10 raised to negative 6 coulomb per meter. The distance from the wire is 0.05 meters. The permittivity of free space is constant. Now, the formula for the infinite charge wire, we have the following here. So you just have to plug in those values for you to able to get the answer of the electric field near a long charge wire. Now, substituting those values from our solution, again, we have here the lambda or the unit of the length of the wire, 2 pi, the electric permeability of the space, and the small r is the distance or the distance of the radius from the center or from the axis. Now, the value of the lambda is 2.0 as given in the problem, 2.0 times 10 raised to negative 6 coulomb per meter, then 2 pi, then electric permeability of free space, then the distance or the radial distance from the center or axis is 0.05 meters. Then you just have to manipulate the equations. Then solving that, you will have the following final answer through your calculator, which is 7.18 times 10 raised to 4 Newton per coulomb. Now, for the last sample problem, we have here the flux through a spherical surface which has a radius of 0.40 meters that encloses a charge of 6.0 times 10 raised to negative 6 coulomb. And then we have to find the total electric flux through the sphere. We have the following given values. The charge that is enclosed, the total for that is 6.0 times 10 raised to negative 6. The radius of the sphere is 0.40 meters, which is not needed in Gauss law formula. The permittivity of free space is constant as always. Then, by Gauss law, since we are talking about electric flux, which is different from electric field, the electric field is the region where it experiences the electrostatic from the charge wire, while the electric flux tells how many electric field line is allowed to pass through on that sphere. So now there's a difference between that. Okay, so the formula for the electric flux is this one here. And you try to solve this by plugging on those values that are all given. So for the solution, we have here the following for the Gauss law. And then substituting the values you have for the total charge, 6.0 times 10 raised to negative 6. The permeability of free space here. And then perform the operation, you should have the final answer of 6.78 times 10 raised to 5 voltmeter. So what else? Well, that's the final answer. And I want you to explore the solving process of this since we already have the solution given. The trick is, you know the formula to use or you know how to derive since we already have identified them during this lecture. So that concludes our discussion. Thank you so much.